Okay? Alright? I don't remember the order I did these in, but I'm assuming I did them in the same order we did. Okay, so way back the first day of this chapter, we were talking about doing the area and perimeter. First thing we did was parallelogram. Okay, which, remember, right, that's just based on height. Same with the rectangle. Keep it in mind, remember the base and height, always creating a right angle. Okay, then from there you did the triangle, right, because the triangle is half of a rectangle or half of a parallelogram, so it's 1/2 formula. Again, base and height, remembering always creating the right angle. We had a trapezoid, okay, which was the same thing as a triangle. And I've always said that, right? Trapezoids and triangles are extremely similar, especially formula-wise. It was just the trapezoids, remember, having two bases. Then I think after that I probably have, oh no, we got rhombus and kite, which again, this can be applied to 1/2 D1, D2, right? Diagonal 1, diagonal 2. Can also be applied to squares or anything that counts as a rhombus, which would be a square. Then after that, this is when we did all of the regular polygon stuff. Okay, we spent a couple of days on that. Actually, probably more like 3 or 4 days. You know what? And we did the different types and the different situations. Okay, so you had the basic regular polygon formula, which works for all regular polygons. The 1/2 apothem times perimeter, or you could have done 1/2 apothem times number of sides of the side length, which is the perimeter anyway. All right, but then remember there were special situations that fell into all the regular polygons. There was the equilateral triangle, which if you have the side length of an equilateral triangle, you can just square the side, multiply by the square root of 3, and divide that whole thing by 4. Okay, so that was one special situation with the regular polygon. And then that one, you remember, led into the hexagons, which was the equilateral triangle formula times 6, right? Because the hexagon is made up of 6 equilateral triangles. And then let me see if I got the other one. I can add, remember we have one other thing we can add to that regular polygon stuff. And then the last bit we were doing before break was the circles and the sectors. Okay? And also the other thing I was going to say you can add, remember with the regular polygon, or with these, remember if you're given the radius, remember you can always do that. Area is the number of sides times the 1/2 AB sine theta. Okay, that was that other formula. Remember that was the other formula for a triangle we did. That was only if we had the radius. Essentially, we find the area of the one triangle and then multiply it by the number of sides. Okay? And all the time remember, and with this formula, guys, remember this is the A and B here, these two numbers. That was the radius. So it's actually radius squared. And this C, remember, guys, was the 360 over the number of sides. Okay, just to remind you of that one. That was just the alternate formula one. Okay, which I'll probably use for that. If I remember correctly, one of the examples we do today involves that. Okay, so that's all the ones you're doing today. And everything you're doing, guys, is all area today. Okay, it's just area of shaded part, which means it's going to be any combination of the shapes up there. It's just going to be, you're going to have a big shape and then something's missing from it. Okay, I'll show you common ones that come up a lot, and maybe ones that might not. And it'll lead into what we're doing tomorrow, because tomorrow's probability, but it still revolves around you being able to do all of the formulas that are up there and all the problems that we use today. Okay? All right, so moving on, right? Good? So, just show you an example of what the thing you're doing today. Okay? Like I'm going to go through some separately, but I have all the work after this. Basically, the idea today is you're going to have a picture there, write a diagram. They're going to have, like I said, some shape, and they're going to have like the whole thing shaded in, just they're going to have parts missing from it. Like this one here, if I was looking at it, I would see that the big shape there is a square, and I know it's a square in that case because I've got both sides being 18. Okay? And I would realize that there are 4 circles that are missing from it. And it, like what it comes down to is you realizing like, are the circles the same? Are they different? What's the radius of the circles? That's the tricks to doing these. In general, the way I'm going to tell you to do this is if you take the time and write out first in words what's involved in the problem, it's usually hard to screw it up. Like if I actually had written out, I see a square and then 4 circles. I would know, like looking at it, that I need to find the area of everything that I wrote out. So I need to find the area of the square, and I need to find the area of the 4 circles. Okay, that's if I was doing this one. Now, the thing I have written up there, it says total area minus unshaded area equals the shaded. It's how you're going to go about it majority of the time. You may run into a couple problems, guys, where you're going to be better off adding together shaded regions. But that case is only going to be if you've got like a big shape and there's just a little tiny chunk of something missing, and that little chunk is something that doesn't fit into the area formula. Like a common one that I can think of that way, I don't know how much you run into it, would be if you have like a circle, and I have like this entire thing shaded, except for this little sliver gone. If I was doing a problem like this where I had a circle and everything was shaded with the exception of a little part here, I don't know how to find the area of that little part, so I can't do the thing that's up here. So what I would do is I'd probably break it up into a sector and then a triangle. Okay, but that's the only case where I would say to go away from what I have written right here. This right there is going to work for you guys like 95% of the time. Okay? All right, just keep that in mind. You know, if there's something that you can't quickly figure out using what I have written there in terms of you don't know what every shape is that's there, like you don't know what the big shape is or you don't know what the circles are, you're going to have to break it up into shapes you know. You might have to add lines to it. You might have to create other shapes inside it, whatever you need to do. Okay? All right. Might have the examples I have. I'm sorry, can I go past that, guys? Is that okay? Alright, so these are the 2 we're going to do. Alright, so for both of these problems, these would be very common ones, guys. Circles get used a lot. Usually squares, maybe a rectangle also gets brought up quite a bit. And triangles, but those are the easiest probably to work with and find. Okay, so guys, the problems are going to be simply, and I'm going to go through, these should be actually pretty easy ones to do. But your whole process, like I said, is if I gave you these problems and I said, what's the area of the shaded region? Okay, so I'd be asking simply for this outside part here, that part out there, so on. The first thing I would say do, okay, even if you know exactly how to do it or go about it or whatever, write out in words what you need to work with. Such as on the one here, this one on the left. There's 2 shapes there, correct? Are there? And they're both what? Circles. So I would say, look, if I want to find this shaded region out here, I know I've got 2 circles. I've got a big circle, and I've got a small circle. So I know right away I'm going to do area of the big circle, and I'm going to subtract that small one from it. Because if I do the area of the big one, okay, area of the big circle, guys, if I actually shaded it, would be this whole thing, right? So the whole idea is I'm finding the area of that solid, and and I'm subtracting that little one from it. So whatever's going to be left is just going to be that shaded part of it. Yeah.
I know it's only like the one like but with the area of the non-shaded region, also the area of the shaded region in that case.
Still we'll work it out. Alright, so here's the thing. Alright, so I'm going to subtract. Okay, now, again, the reason I say write down words is then you can break it apart into now two problems. One problem with this bigger circle, one with the smaller one. Because the problems today, guys, they just end up being multiple area problems. Okay, it's just a matter of you're going to work with them separately, and at the end you're going to bring them together and subtract. Alright, so circle, guys, is pi r squared, correct? Right? Pi r squared is the area of the circle, correct? Yeah. Right. What's the radius of the big circle? 4. So I know this one is pi 4 squared. What's the area of the small one? Or what's the radius of the small one? 4 squared is how much? It's 2 squared? 4. So I know when I do total area, the shaded region here, it's going to be 16 pi minus 4 pi, which is, what's 16 minus 4? So there's your answer there. 12 pi square inch. Okay? So that would be the answer for the shaded region right there. Okay? If I did the one over here on the right, what's the big shape? Circle. So I've got here a circle. What's missing from it? Could be a square, yeah. You put something inside a circle like that, could be. Okay? Again, area of the circle is pi r squared. How do you find the area of the square? How do you find it? Okay. That's squared based on height. All those work. It's probably going to be a little easier way to do this one here then. Remember I said, and I've said before, square is a rhombus. That thing right there is a diagonal. If they give you a diagonal, just do 1/2 d1 d2. Because in the case of the square, guys, both the diagonals are exactly the same. So I know if that's 16 going that way, it's 16 going the other way. It saves you time, so you don't have to actually find the side length and write it out. So when I do the problem here, and this is only because I have the diagonal. If I had the side length, I would use the side. All right, so my circle, guys, would be pi. What's the radius of that circle? The 8 or 16? 8. It's 8, right? 16 is the diameter. All right, and then the square would be 1/2. Diagonal 1, diagonal. Okay, 8 squared is how much? 64 pi. What's 1/2 16 times 16? 128. All right, and then look, that's your answer, guys. Okay, just leave it that way. These don't combine. That has a pi, that doesn't. They're not like terms. You can't combine. Okay, so to stay there, you would just put the units on the end. The only time you'd actually have to go in and work it out and subtract them is if I said like round to near 10, round to near 100, whatever. If it doesn't say anything about rounding, just leave it. Don't give yourself more work than you need. Okay? Alright, so the thing is, guys, like I said, the process to this should be fairly easy and straightforward. I mean, it's the same process every time. Right amount of words, match the words up with whatever the area formulas are, and that's it. Okay? And that's the hardest part. Can you go past this?
Yeah.
Alright, these are the last two I'm doing. Okay, so you do the one, the left or right first? Doesn't matter. The left first? So the one here. Again, same thing. Find a shaded region there. What shapes are involved? Triangle and a regular, is a regular pentagon? Is that kind of, all right, so I got a regular pentagon. All right, I'm going to subtract the triangle. Okay, is that the radius, the regular pentagon? Is it? Yes or no? Yes. Okay? So here's the thing. Remember, this is the one I said, if you got the radius, all you really need to do is find this angle measure, right? Because that's 6. And then we're going to do the alternate formula for the triangle. Because remember, the other area for the triangle, you can do 1/2 AB sine of the angle between them. Okay? So this angle right there, remember, that's 360 divided by the number of sides. So what's 360 divided by 5?
63 divided by what?
36.
It's 73.
Okay. All right, so the way I'm going to set this up is, for the triangle, it's going to be minus 1/2. The AB part for this one is 6 times 6, and then sine of the angle between them. And then this formula, guys, that's the exact same thing I'm going to have over here for the pentagon. Just remember, it's made up of 5 of those, so I'm just going to multiply that by 5. All right, and remember, this is the much quicker way. If you want to go back and do the 1/2 AB stuff, that's fine. Okay, it's just a little quick. Now, in these cases, though, I do need some decimals, so I need someone to multiply all that stuff together.
I'll do it. Oh, wow.
All this right here. Well, just each one. Like
Okay.
do the 1/2, 6 times 6 times the sine of 72. All that. 18 times.
72. That's 17.1.
17 point what?
Wait, I didn't finish. 72 times 5.
Well, no, that's fine. What's this one? One.
Okay. All the parentheses all together on the left side is 17.119.
That's right. That's what I'm saying. That's this side. So just multiply that by 5. Then.
Yeah. Times that by 5 is 85.595.
Okay. So 0.6. So if I subtract those, or I just could have done, you know, 17.1 times 4.
Wouldn't that be like 68?
Okay, calculate.
Shut up.
Come on.
It's 68.495.
6.5.
Yes.
All right, so that'd be the answer for this one. I think it is. Okay, about the one on the right. What do you think I should do here?
Oh.
Yeah, but
Find the area of the two little squares, add them together, and subtract the two little squares, add them together to the whole thing. Or
yeah, okay. Or what?
You could just do, you could find the area of the whole thing and then subtract by 16 times 2.
Same thing you did.
It's 12 times, it's 12 times 8 and all that.
That's right.
Minus
Okay.
16.
I'm just saying, it's the same thing. You're right. All right, so you're saying 12 times 8, right? 12 times 8,
Yeah.
that's my rectangle.
Yeah, you're right.
Minus 8 times
96
Minus 2 times 16, right?
32, yeah.
Okay, which is the 2 squares.
Yeah.
So 12 times 8, that much?
96 minus 32 is 64.
Look, guys, honestly, on both of these right here, if you didn't want to do the subtraction stuff, it would work fine. Because of the idea of the one on the right, or the one on the left, I mean, there's 4 of those triangles shaded in, so you could have just done 4 times the 17.1. Same thing goes over here. You break it up into the squares. There's 4 of them shaded in, so I could have just done 4 times 16 instead of doing subtraction. If you can find shorter ways to do them like that, as long as it makes sense in the work you're doing, that's fine. The subtraction thing will work every time. Okay? But if you realize these things are broken up evenly like these two were, and you just want to multiply it by however many parts are shaded in, that's fine. Okay? You're going to get the exact same answer. Alright? Okay, so that's all we're doing, because these 2 days are usually